Differentiation example 7. Find the equation of the normal to the curve f of x equals 8, take 3 root x at the point where x is 4. So key word there, normal to the curve. That's going to come into play when we are thinking about the gradient. So first up, we need to differentiate this because it's a curve, and the only way we can find the gradient of this curve is to differentiate it. So it's 8 take 3 times root x. Now that's not in a format we can differentiate. It needs to be a power for us to differentiate it. So we use what we know about indices, and we rewrite root x as x to the power of a half. Now it's ready to differentiate. So on the left hand side, after I've differentiated, it'll be this f dash or f primed. Differentiate a constant, it disappears, so the 8 vanishes, and this next term multiplied by the power of x, so minus 3 times a half is minus 3 over 2, and then take away 1 from the power of x. So we've differentiated there. Now we want to find the equation of the normal at the point where x is 4. Now this will give us the gradient of the tangent. We must bear that in mind. We don't want the tangent, we want the normal. So let's sub in 4. And remember that'll give us the gradient of the tangent. We'll then need to do something with it to get the gradient of the normal. So let's sub in 4. Minus 3 over 2 times 4 to the power minus a half. The power of minus half is only affecting the 4, not the minus 3 over 2 at the front. So minus 3 over 2 times 4 to the minus half, that's minus 3 over 2, times by, well, negative power means 1 over. So we've got 1 over 4 to the power of a half, which is the square root of 4, which is 2. And multiplying fractions is dead easy. Multiply the top numbers together, multiply the denominators together. And that's the gradient of the tangent. We need the gradient of the normal. So say therefore, the gradient of the normal, well, it's going to be the negative reciprocal of that. Think back to the coordinate geometry chapter. We know that perpendicular gradients are negative reciprocals of each other. So we do the reciprocal of this, which effectively flips it over, and we change the sign. If it was negative, we make it positive. If it was positive, we make it negative. We covered that in the coordinate geometry chapter. So now we know the gradient of the normal at the point where x is 4. We're going to be using y minus y1 equals m brackets x minus x1 to get the equation of the normal, and the normal being a straight line graph. Thing is, we don't have a full point to put into this formula. We've got the gradient, we've got an x coordinate, we don't have a y coordinate. So let's quickly work out the y coordinate when x is 4. So subbing 4 into this, we get 8, take away 3 times the square root of 4. The square root of 4 is 2, 3 times 2 is 6, so it's 8 take 6, which is 2. So this line, this normal, is going to pass through the point x is 4, y is 2. Now we've got all the ingredients, let's sub everything in. So the gradient is 4/3, and it goes through 4, 2. X is 4, y is 2. X is 4, y is 2. Now the question didn't tell me how to leave my answer. So if that was a real exam question, I'd have full marks now. But just for practice, I'm going to simplify this. Now usually when we have a fraction here, usually we do something to this equation so that we don't have any fractions anymore. So in this case, I'm going to times the whole equation by 3. On the left, 3y minus 6. On the right, 4 brackets x minus 4. Both sides now are 3 times bigger. And that's okay because it's an equation, so I have to do the same to both sides. Now I'm just going to expand the brackets on the right hand side. Please remember the question didn't tell me to do this, just doing it for practice. And generally what we do, we drag everything over to one side. So I'm going to drag everything over to the left-hand side. So 4x will become minus 4x. 3y stays where it is, so it stays positive. And drag the minus 16 over, it becomes positive 16. And positive 16, take away 6, is positive 10. Now if I stop now, this is wrong, because it's not an equation. The right-hand side of our equation from the previous line is now 0. And if we don't write it, then it doesn't mean equals 0, and therefore is wrong. So we must write this. That's the end of example 7.